Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with some geometry, and it specifically looks like something around congruency. So we're going to move straight into it. In the given figure, P and T are points. P and T are points on a circle with center M. So those are points on the circle that is center M, which is very important. N is a point on chord PT, so that's a point over there, such that MN is perpendicular. That's very important. So that forms some right angles at point N. They've said to us, prove that Pn, so I'm going to mark this in a different color. They've said to us, prove that Pn is equal to Nt. Right, so before we can get there, we need to do some proving of the congruency of the two triangles. Now this is a very difficult question to get to the end or to answer if you don't think of congruency. So try and keep congruency at front of mind when a question like this comes up. Right, so let's get into our congruency answer. I'm going to say, and I'm always going to structure this really neatly, in triangles, and I'm going to write triangles NMP, so NMP, and, okay, but just below I'm going to write triangle NMT. Okay, now we need to find three reasons for them to be congruent. What is the first reason? Well, they've said to us that M is the center of the circle, which means that MP and MT are radii. So that means that MP must equal MT. So I'm going to do that first. So it's going to be MP is equal to MT, and that is as a result of radii. Brilliant. Now we move on to the second point. Well, we know that N2 is equal to N1, which is equal to 90 degrees, and that has been given to us. Very importantly. And then finally, for 3, we have got that NM is common. And that gives us 3 things. Therefore, we can say that triangle NMP, and I apologize, I'm running out of space, is congruent to triangle NMT. Try not to go outside of the lines. And the reason here, what have we got? Well, we've got a side, okay, but a very specific side. Do you notice how these are our hypotenuse? Then we've got a given angle. So we've got an angle, okay, and then we've got a common side. So in this instance, our reason is going to be right angle, hypotenuse, side. That means because those two triangles are congruent, we can conclude, therefore, that Pn is equal to Nt, and our reason in that case is going to be that triangle NMP is congruent to triangle NMT. Done and dusted. Really good job. Hopefully this helps you out. There are probably other ways to prove the congruency. This is only one of them. Another way we could have done it is by proving that there is an angle over there. That might not have worked because we wouldn't have been able to prove the included angle. So again, this is a trial and error game, but the most important thing is that you've got congruency at the front of mind, and that you're able to prove congruency. And once you've done that, you'll be able to prove that the two sides that they've asked to prove equal are equal. Thanks so much to our sponsors for making this video possible. Read all about them in the description below. Remember to check out our website for more of these epic tutorial videos. If you can't find the answer to your question, remember you can send us your question and we'll respond with a personalized video just for you. Until the next time, stay epic.